Next up, we are learning about some advanced concept of C++ object-oriented programming. Like we have abstract class, pure virtual functions, and composition versus inheritance. We have our prompt ready, and let's go with that. Advanced object-oriented concepts, abstract class, inheritance, interface with using pure virtual functions, composition versus inheritance, and then we ask, okay, write some output statements to demonstrate this. And our goal is to teach the beginners or some experienced who wants to know some deeper concepts about object-oriented programming and C++. So we have our prompt and we ask the Copilot to work for us, create the code. Here you go. GitHub Copilot is working and it is started producing the results. We will see. And okay, it's started. Advanced OOP, and we have code getting generated. Vehicle is a class. Car is derived from vehicle, and that's base and drive class object. Motorcycle is also a vehicle, and we have some display function. Then we are working on interfaces with pure virtual function. We have pure virtual functions, and we have electric car derived from car and electric, multiple inheritance. And then we got self-driving car and autonomous. And some switch and case statement. We got engine, transmission of vehicle car or electric car. We'll see what it did. And we got vehicle with composition. So we're talking about inheritance and composition, differentiation, then abstract class demonstration, and is still going, demonstrating interfaces. Then that's main. All right, it did in a minute or so. Demonstrate abstract class, demonstrate interface, demonstrate composition versus inheritance. Those three we asked to explain and generate code for. Abstract class is here, and it did interfaces with pure virtual functions, electric and autonomous, and those electric car and self-driving car. And the composition versus inheritance, this is easy or has a relationship. Like inheritance is easy, like base class and derived class. Has a means one class contains another class. That's composition. And those are demonstrated here. And let's take the code to the editor and then start executing and seeing the result that we expected from this. And our purpose of learning the advanced concept of abstract classes and composition and so on, advanced object-oriented concepts in C++. So we do have to take the code to the editor, and we have editor in the middle, and our advanced OOP.cpp will create and apply in editor and create a new file and advanced OOP.cpp. This is the file, and in CPP folder, okay, advanced OOP, and that's the file, advanced OOP. And let's hide the chat window for now. And that's how we do. And we bring this to balance so that we can go through the code and the output. So let's see the file it has generated. That is advanced OOP. We just saved that. That's the time. And we do have to compile. C++ is the compiler. File name you put it, and then you do output file, and then you have advanced OOP. I'm keeping the same name without the extension, and it compiles successfully. We do ls-ltr, we'll have the advanced OOP. And this is executable binary file. And let's execute. How do we execute? We saw that before. Clear and add advanced OOP. And once we execute, it has to generate, it will generate some output as per the code. And we go through the code and understand what it is doing. The main is in the bottom, the demonstration of abstract class interface. Those functions are here. We'll come back to that. And let's talk about the class. Class is on the top. Vehicle is a class, base class. Looks like this is also an abstract class. That means that a pure virtual function, there is no definition, and also equals 0 when you declare that function or method. So we cannot create an object of vehicle. So because a vehicle has to be something like car or train or any other. So car is derived from vehicle, and all vehicle has a make, model, and the year, and car has engine size and number of doors, and motorcycle has no doors, has sidecar maybe, and it also has no engine size as per this. And we have electric. This is the interface with pure virtual function it is working on. So we have electric is a class with all pure virtual function. Autonomous is a class with pure virtual function. That means they're abstract class. And electric car is derived from car and electric. So we have car class above and electric. So electric car has a battery and a capacity, and then some other functions. We will go through that. Self-driving car is car and autonomous, and it has autopilot active or not active that we can have. Autonomy level, what level it will be. There is a level is a type. Yeah, level 0 through 5. 0 is no automation, 5 is full automation, and some are in the middle. So what do we have next? Self-driving car, engine. Engine is another class, which is the engine type, displacement, horsepower of the engine. So where we use engine and transmission, those two are classes. They are derived by, or not derived, they are actually composition that we are talking about. A vehicle has engine, unique one engine and one transmission, and it's like has an engine, has vehicle has a transmission. So all these classes. So it's nicely put together all the vehicle, car, autonomous, and electric car, then engine and transmission, and so on, and vehicle with composition, and then demonstrate abstract class. This we saw in the main demonstrate abstract class. Let's see that. And our output will be here. Now we can go through the output. Abstract class, abstract class, a car object is created, Toyota Camry 2025, and display information, move function is called, then what it did. Vehicle, Toyota Camry is created, car constructor is called, vehicle constructor is called with Honda, the other one, motorcycle, and motorcycle constructor is called. So one is car and the other is motorcycle. And the display information is showing here. Move, display, displays, Toyota Camry is a car, and all the information. Honda is a motorcycle with other information, fuel efficiency and all. Then we have using polymorphism. Using polymorphism is with base class pointers. So we learned in previous lesson how the polymorphism works. We have vehicle, an array of 2-point vehicle pointers. Vehicle is a base class, and one is sedan, one is a sports bike that we created here, Honda and Toyota. And then using the vehicle, we display the information. It should be displaying the same. Vehicle 1 is Camry, Toyota Camry, and vehicle 2 is motorcycle, Honda, and so on. So it is in the for loop using the base class pointer, and pointer, when we have to use arrow notation to call the function. It will call the method or function of that particular derived object, like sedan or the bike. So some explanation here. Key points about the abstract class. Abstract classes cannot be instantiated directly, that we know. If there is a pure virtual function, that's abstract class, and abstract class is not allowed to be created an object with, for, object for. And they contain at least one pure virtual function that we saw with this notation equals 0 in the declaration. They define an interface with the derived classes must implement. So those functions, pure virtual function has to be defined or overridden by the derived class. And they enable polymorphic behavior through the base class pointer that we saw, the vehicle as a pointer, and using that we can call the derived class function. So that's what it is. Now demonstrating interfaces. So we saw that this is what it is. Interface, oh, here is the destructors are called in the previous section, previous function. And interface demonstration is here. And we have same thing, it is creating electric car and self-driving car. Waymo is self-driving car, Tesla electric car. They are given an electric car. The self-driving level 4 is initialized with, and these are enumerated value. There's a 4, and we have display information Tesla, and then self-driving. The constructors are called here. And Tesla informations are displayed here. that what we have initialize with battery level for 100, initial range, or like that. All these are taken care in the Tesla class object in the electric car. When we say display information, all these informations are displayed. Initial battery are here. Initial battery range are displayed here. And that is the derived class function tank. Or whatever, and it is the value from the base class or the derived class, range, battery. And then we do move that function call, and then battery level after moving. So some changes happen. That's what it says, 95% now, and the other thing changes. And display information, those are updated. When it is charged, when it is moving, battery goes down, and charging, battery goes up, and so on. And then Waymo display, Waymo here, autonomous car displayed, and using move when it moves, and then activate autopilot. When autopilot activated with autonomous Waymo autonomous car, self-driving will be self-driving car moving autonomously on the road, and deactivate autopilot, then it is here. Now, electric car. So it is the electric car is a pointer, is a base class. We saw that. Tesla is the object, and using that, this is polymorphic behavior. Using that pointer, you can display the charge and battery level and all the things. Same thing, autonomous vehicle is another pointer for the autonomous base class. Waymo is the object class. The object class address is assigned to this. And using this pointer, this autonomous vehicle pointer, you can activate you can call the activate autopilot. And some description about key points about the interface is interfaces in C++ are classes. Those are classes, like an abstract class, you can say, pure virtual function, with only pure virtual functions. There is no definition of other sort. They define a contract that implementing classes must fulfill. The derived class must define those functions. The class can implement multiple interfaces, multiple inheritance. It can, is not necessarily. Interface enables type-specific operations through polymorphism. They promote loose coupling and extendability. Those are the qualities of these behavior in the object-oriented concept. Next, composition and inheritance. We saw those classes, car, inheritance, car, and then we have, let's see, the composition here, inheritance approach, easy. So we have the car has a base class, and the base class uh, inheritance car, and electric car, also multi-inheritance example. We had that electric car, and the composition here is composition. Yeah, we saw the vehicle with compositions. So inheritance we have learned earlier also. The main thing to differentiate is composition. A composition car has an engine and transmission as the object within this object. So that's a composition. Using that, you can call start. Start is, we'll call the engine start internally, and accelerate will do transmission. When you do it, when you accelerate, transmission class will do that. And then it is done with the description. Inheritance is a concept and composition has a concept, meaning the properties of the base class comes to derived class, but in composition, the one class contain another class has a relationship. It creates a rigid hierarchy like this. Electric car is a car that we saw, and derived class inheritance, and in composition creates flexible object relationship. Car has an engine, so this can change. That you can replace the engine with another engine, or V8. Instead of V8, you can have V6, and so on. So design principle is you favor composition over inheritance. This principle suggests using composition for more flexible designs so that you can replace, like, transmission or engine, you can replace. But once you have an easy relationship, that stay together. Like changes of the base classes affect all derived classes. But in this case, it may not. And limited to single inheritance in many languages. C++ allows multiple. Okay, so that makes sense. Other languages only allows single inheritance, but you can have multiple composition like transmission, engine, and many other. So all these concepts are very important about advanced C++ concept. So we learned about that, and I think we covered everything here in this lesson. And with that, I have we have concluded advanced object-oriented concept. We have still a lot of things to learn about C++ and object-oriented concept. We are not done yet, but this is all, we are already in advanced concept. And with that, thank you so much. I'll see you in the next lesson.